Hello, I'm back. We're just going to talk a little bit today about maybe some basics of troubleshooting around a PLC. I'm going to attempt to clearly show you, a few tips on troubleshooting with the meter, and if the glare's not too bad and you can zoom in and see what's going on in the program, that's cool. You'll benefit from that. You may want to watch the video a few times. You may want to watch what I'm doing up here and then zoom in and see that. But if the glare is bad, don't worry. It's not going to be worth me redoing the video for, because the next video, when we talk about logic, I'm really going to zoom in on the program, because when we start talking about logic, it's going to be important that you see this ladder diagram and how they change and what the logic, just basically how the logic works. So next video, if you can't see this, you'll see more of this. But for right now, we're really going to focus on just kind of how the current flows through and how a few tips that we might use to troubleshoot. Okay. I'm hoping you can see this readout. If not, I will be redoing this video because that's kind of important. But I've noticed that you have a harder time seeing it when I put the light on than when I don't. So you may have to zoom in to this on your computer, but usually you can kind of see it. Okay. So remember, we kind of talked about PLC and control circuits. I don't know how that word eluded me. Control circuits. Anyways, sometimes my brain works that way, but I know more what I'm doing than how to say what I'm doing. So just watch what I do, sometimes not what I say, right? So let's just say, usually you might not be called to troubleshoot much, because usually in a big industrial environment or something like that, there are maintenance guys that know this equipment and that do that, and they can do it more efficiently than contractors. But if you're ever thinking about learning enough to become a maintenance electrician, or if you're ever in a position where someone needs you to troubleshoot, you'll at least kind of know a little bit about this. So say you open up a control cabinet, you see all these wires. Maybe the operator says, hey, every time the 10th box goes by this sensor, this motor's supposed to turn on, but it's not turned on. What's wrong? And you're thinking, what could it be? Could it be the sensor? Could it be maybe an overload relay in the motor starter? Could it be just a simple fuse? Who knows? Well, that's, of course, we get our meter out and we see. So one thing you're going to want to check is to make sure the sensor is working, right? So on my PLC up top are the inputs, and you're going to want to know what the inputs look like. Every PLC may be marked a little bit differently. So just because my input lists them as I1 through I4 and IB through IE, there may be another company like Delta who lists an input as DI for digital input. And then, of course, you're on the digital side because their analog is like, I think 1A or something like that. But anyway, you'll want to know first of all, how your inputs and outputs are marked, so that you'll know what to stick your meter on, right? So my inputs are up here at the top, and they're just listed 1A, 1B, one. I1, I2, I3, I being input, right? So let's just say, we're worried about this photo sensor right here. We're wondering if it works. Well, I just, I'm probably not going to knock your socks off. You've probably seen this 1,000 times, right? I put my meter on it. I'm reading nothing. I put a box over it or put my hand over it. I tripped it, and hopefully you can see I'm reading 23.3. So I know my sensor is working. Now, usually there's no problem with the program. It's been my experience that there's usually no problem with the program. So, if you wanted to, you could check the output to see if you're getting an output, and then you could go down the line. Maybe if you're supposed to be getting an output, you could see if one of these relays is engaging. If it's not engaging, maybe you check and see if you get 24 volts to the coil of that. If you don't, maybe there's some break in the line somewhere, a fuse out. Of course, if you are getting a contact, you might want to check your line voltage. But, these are just ways that you can stick your meter on, and, you can check to see if you're getting an input signal, or if you're getting an output signal, or if with these DC wires down here, are we getting a signal at our coil? And that's just kind of how you troubleshoot. Hopefully most of you kind of can follow this and get this, but I just want to make sure that everyone knows how to troubleshoot. Of course, part of the reason why we're going to be learning about the program is because in a PLC, you might not realize what's going on in there. There's no moving parts. Sometimes it's hard to know what leads to put your meter on to see for troubleshooting. So sometimes you can get a copy of the plans, and the plans will show, hey, this sensor goes to this input, this contactor goes to this output, and the plans, the ladder diagrams can help you to learn to troubleshoot. But sometimes in the PLC there might be a more complicated program, like there might be different settings. I'm going to throw out a technical jargon, a data register, which we'll talk about later. A data register may be used. That means basically the operator may be able to put different settings on maybe a counter. So maybe you have to trip an input several times to get an output. But you're going to want to at least know that there is a program in here, and if there's no one-line diagram for that program, there might be a maintenance person who might be able to get into the program and answer some questions and let you know how to use an input to trigger an output for troubleshooting, okay? Because there's some other tricks if you can't get into that, but they're pretty risky. I'm not going to mention them because you could miswire something and screw something up, and I don't want to be the guy that inspired you to destroy millions of dollars worth of industrial equipment or hurt someone. So yes, there are ways, if you can't quite get into the PLC program, there are tricks to troubleshooting. It usually has to do with bypassing things, but let's just focus on knowing what's in the PLC and knowing there is a program that usually someone can get a hold of. And worst case scenario, they can print that program off for you, and you can see the contacts, and you can say, hey, there's this photo sensor is used as a counter, and I need to trip it 6 times to get my output. And then, we can troubleshoot from then. So that's pretty much what we're trying to learn. So, I just kind of showed you what was on the meter. Let me show you what's on the computer program when we trip these inputs and outputs. I almost forgot to do that. That was one of my objectives. So let's open up this program. Okay, as you can see, I've got a program in front of me. Hopefully you can zoom in and see that. Right now, my input 2 is triggered, and that is one of my photo sensors, and I bet you anything, I just triggered it because I got something in front of it. So let's move some items. Okay, see, if you're wondering what I'm looking at this yellow box down here. I have 8 inputs, so the bigger box with 8 is going to be my inputs, and the smaller box with 4 is going to be my outputs, because I got 8 inputs, 4 outputs. One thing that you're going to notice is when I trigger an input, the input lights up. That lets me know that, hey, I'm getting a signal to this input. If you're ever in a troubleshooting environment, that's kind of how sometimes maybe a maintenance person might be able to look at the program and tell, maybe, is my sensor sending a signal or something. So let's start with the inputs. I'm going to trip my I1. You see my I1 turned yellow because I basically just tripped it. I basically just sent a signal, and that's what it looks like. As well as, if you can see this diagram up here, my I1 is up here. It is shown as a normally open contact, so we know under normal circumstances, when there's no signal, that sucker's going to be open. There's not going to be anything going to the as an output. It's a normally open contact. Sometimes in some programs, contacts look different. We'll talk about some different programs and how they look, but this is on the Schneider Zelio Logic program. This is a normally open contact. So this is a normally open contact, and you'll notice I trip it, normally open closes, sends a signal down. The reason why I'm not getting an output is because I've got my input 3 off. I don't want a whole lot of lights going off to distract you. We're just looking at inputs right now. We will look at that here in a second. My I4 is a push button. You can pay attention to this. This is my input, normally open input contact for my I4, as well as my I4 will show you that I'm getting an input there. Push that. I will have to warn you from time to time, my computer is slower than my PLC, so sometimes we're kind of waiting on the computer to catch up and register, but it is what it is. I'm on a budget here. So as you can see, I push my push button, and as long as I hold my push button down, my input is closed. My input is getting a signal. And what this is, this says that I am getting a signal, a positive DC voltage signal. It's going through this momentary switch. I'm holding it down, and it is right now, as that's lit up, it is getting a 24 volt signal. So if I were to stick my meter across the negative and my input 4, I would get 24 volts. You've seen that, so you can understand that, right? So that's pretty much the inputs and how they're seen in the program. And let's see here. Oh, right here, if you can read this, this says A1. This is not necessarily an input. This is called an analog comparator. I actually have an analog signal with my potentiometer that I have set up to analog channel 1D. I'm going to show you how that looks because analog's a little bit different, but I have set my comparator up so that when my analog signal reaches 5 volts, it sends an output. Analog signal is one of those things that it can read like 0 to 10 volts, and so I can ramp up my analog signal a little bit by little bit, and it won't do anything until I reach 5 volts, and then it'll trigger an output. So let's look at that. Let's look at that on the meter and look at that here. I'm actually going to close input 3, so you'll see input 3 engaged. I'm going to close it. The reason why is so that we can see the output. Okay, so let's see here. Let's see here. So my analog channel that I have, I believe, is 1D. Yeah, it's going to be 1D. So I'm going to turn my potentiometer up. Oh, hold on. My potentiometer is kind of already on some voltage. Okay, so I turned it down now. Now you will see this is basically 0 volts, 0.04. Okay. As I move this potentiometer, you're going to notice the voltage is now 2. Well, if I keep my leads on it correctly, the voltage is 2.65. There's no output because I haven't reached 5, but you can see kind of how an analog signal works. It can be different voltages. Once I reach 5, there you go. There's my output because I am at, oh, my meter just turned off, but I believe I saw 6.41. Let's see if I can get it again. Yeah, 6.41. So my output's on because I have 6.41. I will turn my voltage down, and right now I'm at 2.19, so my output's off. An example of why we would use something like this would be, say if you have a sensor that senses something along a continuum, maybe a temperature sensor or a pressure sensor or something like a scale that senses weight. You're going to have a lot of different values, and so this analog signal will actually send a strength of signal saying, hey, what temperature is this, or what pressure do we have? And then maybe if it's a pressure sensor, once our pressure in the tank that we're monitoring goes above or below a desired pressure, maybe some solenoids will open or shut to increase or decrease the pressure or something like that. But that would be pretty much what you use an analog sensor for. There's also analog outputs, although I don't necessarily have any analog outputs on this, but there are analog outputs, and an example that they would be used for would be motor speed controls to a VFD. Just like the voltage changes, it'll tell the VFD what frequency to run the motor, and that will ramp up or ramp down the motor. So, analog also, the PLC doesn't necessarily read the analog as you think it is. The PLC actually reads the analog in bits, and there is something called scaling, which we have to take the number of bits that the PLC is seeing and translate it into usable information, whether that's volts or whatever. And we'll actually, in a future video, get into scaling some analogs so that you can kind of see how that works. But just know that, hopefully this kind of has been a way of me showing you how the circuit works a little bit, how you can use your meter to troubleshoot a little bit. Maybe you've been able to see what it looks like on this program, just to kind of give you a taste of these things, and we're going to get into some more complicated things as we go on. So if these videos are seeming too simple for you, don't worry too much. You might have to fast forward to a few videos once I get them up, because we're just going to build on our knowledge. Okay? Thank you. See you next time.